Hi students and friends, welcome to the channel Learn and Teach by Ayaz. So in this video lesson, I'm going to solve the paper 11 for 5070 and the year is May-June 2023. I'm not going to read the instructions as you all are aware about the instructions of this paper. Total marks for this paper is 40. So let's begin the paper. Here's the first question. In a change of state at constant temperature and pressure, energy is released as stronger force of attraction form between the particles. The average distance between the particles changes very little. Which change of state is being described? If you read the statement, they are saying that stronger forces of attraction form. So you know that in the gas state, there isn't any strong force, but in liquid and solid, there is stronger forces as compared to gas. But in solid state, the force is greater. And what they are saying that average distance between the particles changes very little. It means that it indicates the state is not gas. The initial state is not gas because in the gas state, the particles are far away from each other. So there's very little change in terms of the distance between the particles. So C must be the right answer for this question. Number 2, X, Y, and Z are elements. X and Y are in the same period of the periodic table. Y and Z are in the same group of the periodic table. What are possible electronic configuration for X, Y, and Z? Now they are saying Y and Z are in the same group of the periodic table, which means the valence electron will be same for these two, Y and Z. So straight away, I'm going to look at the valence electrons for Y and Z. So A can't be the correct answer. B can be the correct answer because the number of electrons for Z and Y are same. What about C? C is also incorrect because again, the number of valence electrons are different. What about D? In D also, the number of valence electrons are different. As you can see, in Y it's 7, in Z it's 4. So B must be the right answer for this question. Number 3, the numbers of electrons, protons, and neutrons in 4 different particles are shown. So we have particle 1, 2, 3, 4. And here we have electrons, protons, and neutrons. Which particles are isotopes of the same element? What are isotopes? Isotopes are atoms of the same element. Same proton number. Different number of neutrons or nucleon number. So I'm writing number of neutrons because this will give you clear idea about the concept behind isotopes. So look at the particle which have same number of protons and electrons. Remember, the electrons should be same also. So if you look at this clearly, particle 1 and 4, they have same number of electrons and protons, but their neutrons are different. So 1 and 4. C should be the right answer for this one. Number 4. Some statements about the bonding in magnesium chloride are listed. Statement 1. Each magnesium atom donates 2 electrons. Each chlorine atom accepts 1 electron. This statement is correct. Number 2. Chlorine forms an ion with a 2- charge. If you look at the position of chlorine, it's in group 7. Here it is chlorine. And it needs 1 electron to form negative ion. So the charge must be -1, not -2. So this is wrong. Number 3, magnesium atoms and chlorine atoms share electrons. This statement is wrong. Number 4, magnesium forms an ion with a 2+ charge. This statement is also correct. So 1 and 4 is correct. The answer should be B. Number 5, ethane, C2H6 and ammonia, NH3 are covalent compounds. The dot and cross diagrams of these compounds are shown. This is ethane. And this one is ammonia. Which statements are correct? Number 1, a molecule of ethane contains twice as many hydrogen atoms as a molecule of ammonia. If you look at the number of hydrogen atoms in ethane, it's 2 times the number of atoms, hydrogen atoms in ammonia. So this statement is correct. Number 2, an unreacted nitrogen atom has 5 outer shell electrons. If you look at the position of nitrogen in the periodic table, here it is. It must have 5 valence electrons. So this statement is also correct. Number 3, in a molecule of ethane, the bond between the carbon atoms is formed by sharing 2 electrons, 1 from each carbon atom. So all of these statements are correct. So A will be the right answer for this question. Number 6, when a strip of copper is placed in aqueous silver nitrate, a displacement reaction takes place. What is the ionic equation for the reaction which takes place? So if you look at all the ionic equations, first one seems wrong because in this equation, they are also showing the formation of electrons. It's in fact lost and gained. Silver ion is gaining electron as it is less reactive than copper, and copper is losing electrons. So the final equation, ionic equation, in fact, will be for this question, B will be the right one. Number 7, 3 compounds are listed: calcium carbonate, potassium sulfate, zinc nitrate. Which row shows the element present in the greatest percentage by mass in each compound? So here they provided us with the AR. And we have in the first column, we have element present in the greatest percentage by mass in calcium carbonate. The formula of calcium carbonate is CaCO3. If you will calculate the MR of CaCO3, it will be, we have 1 calcium, so you have 40, 1 carbon, so we have 12, we have 3 oxygen, so we'll multiply 3 by 16, we'll get 48 here, 48 plus 12 plus 40, and we'll be getting 100. So if I'll calculate the percentage of calcium in this, so I need to multiply 40 by 100 and divide it by 100. But for oxygen, I have to multiply 48 by 100 and divide it by 100, which is the MR. So 48 will be the percentage of oxygen, which will be higher in this case. So either C is correct or D is correct. Both A and B is incorrect. So straight away, I will look for the percentage of element present in zinc nitrate. So in zinc nitrate, first of all, I need to calculate the MR of zinc nitrate. What will be the formula of zinc nitrate? It is ZnNO3 whole twice. The reason is that zinc carries +2 charge. So for zinc, there are 1 atom of zinc, so we'll add 65 plus 2 atoms of nitrogen. So we will multiply 2 by 14, we'll get 28. What about oxygen? 2 multiplied by 3, 6. And 6 multiplied by 16 will be 6, 6, 36. 6 plus 3, 9. 96. So if you'll add up these, what you will get? 65 plus 28 plus 96. 189. 189 is the MR of zinc nitrate. So 189 is the MR of zinc nitrate. So if you look at the equation, clearly indicates oxygen is present in higher percentage. So D will be the correct answer in this case. This is the right choice. Number 8. Two aqueous solutions Q and R have the same concentration in mole per dm cube. Solution Q contains 4 grams of NaOH in 500 centimeter cube of solution. Which solution could be solution R? So what I will do, I need to calculate the concentration in mole per dm cube for NaOH. The grams of NaOH is given. So I'm going to calculate the MR of NaOH. MR of NaOH. Na is 23. We have one oxygen, 16 plus 1. So it becomes 40. So if you divide 4 by 40, what you will get? 0.1. And this 0.1 is in 500. 500 centimeter cube contains 0.1 moles. Therefore, 1000 centimeter cube contains X moles. So it will become X is equal to 0.1 multiplied by 1000 and divided by 500. So 500. So 2 multiplied by 0.1 will get 0.2. So 0.2 mole per dm cube. One of these must have 0.2 mole per dm cube. What about the concentration for A? If you calculate the concentration for A, you will write 250 contains 0.2, 1000 contains X. So it becomes X equal to 0.2 multiplied by 1000 divided by 250 and 4. 4 multiplied by 0.2, 0.8. So this is wrong. What about number B? We have 0.2 mole of HCl in 100 centimeter cube. So I will write 100 centimeter cube, 0.2 moles, 1000 centimeter cube contains X. X becomes 0.2 multiplied by 1000 divided by 100, 110. So if you'll multiply 0.2 by 10, you will get 2 moles per dm cube. This is also incorrect. What about C? 0.05 mole of H2SO4 in 250 centimeter cube of solution. So I will write 250 centimeter cube, 0.05 and 1000 centimeter cube. X becomes 0.05 multiplied by 1000 divided by 250 and it will become 4. If you multiply 4 by 0.05, 4 by 0.05, I will get 0.2. So this seems the right answer. This is the right answer, as you have the same concentration like the one we have mentioned in the question. Number 9, samples of 2 hydrated compounds are weighed and then dehydrated by heating. The anhydrous compounds are weighed and the results are shown. 3.97 gram FeSO4.X2O XH2O gives 2.17 gram anhydrous FeSO4. 2.88 gram CaSO4.YH2O gives 2.27 gram anhydrous CaSO4. What are the values of X and Y? So first of all, I need to calculate the moles for these FeSO4 and CaSO4. So for FeSO4, we need to divide 2.17 by 152. FeSO4, 2.17 divided by 152. 2.17 divided by 152. It becomes 0.014 moles. Okay, what about water present in FeSO4? For this, we need to subtract 2.17 from 3.97. 3.97 minus 2.17. So this is the grams for water, 1.8. So you will divide it by 18, which is the MR of water. So 1.8 divided by 18, we'll get 0.1. So for FeSO4, 0.014 mole reacts with 0.1 mole of H2O. Therefore, 1 mole reacts with X. So we'll get X is equal to 0.1 multiplied by 1 divided by 0.014. So what you will get? 0.1 divided by 0.014. 7.14. So either C is correct or D is correct. So we need to calculate the number of moles for CaSO4. For CaSO4, the moles will be 2.27 divided by 136. 136 is the MR for CaSO4. 2.27 divided by 136. 0.016. 0.016. What about water? In order to calculate the grams of water, we need to subtract 2.27 from 2.88. Minus 2.27. 0.61. 0.61 is a gram for water. So I will divide 0.61 by 18. Then I will get the moles of water. 0.61 divided by 18. 0.033. 0.033. So for calcium sulfate, 0.016 need 0.033 and 1 mole needs X. So X becomes 0.033 divided by 0.016, which becomes 0.033 divided by 0.016. 2.06. So D should be the right answer in this case. Number 10. What has a mass equal to the mass of 1 mole of water? 1 mole of water. They are saying 1 mole of water, not 1 molecule of water. A, 24 dm³ of water at room temperature and pressure. This is wrong. The reason is that they are saying the volume of water. In this volume of water, we don't know the mass of water. B, 1 mole of steam at 200 degrees centigrade, 100 kilopascal per 1 atmosphere. This seems correct. The reason is that 1 mole of steam at 200 degrees centigrade must have same mass of water. So this looks correct to me. For your convenience, I am reading the other statements also. 1 molecule of water at room temperature and pressure. This is wrong. They are saying 1 molecule, not 1 mole. So this is wrong. D, 2 moles of hydrogen molecules and 1 mole of oxygen molecule. This is also wrong. P will be the right answer. I'm ending the session here. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.